Welcome to the first session of our security track. We do have four security themed sessions, one right after another. The first person that's going to be speaking today is Omar Santos. Omar joins us from Cisco, where he has over 25 years experience in security, and his latest focus has been a lot of different things, including AI. Yeah, Omar, welcome.
Thank you for having me. Wow, I guess my voice is a little bit stronger. So thank you and welcome here today. My name is Omar Santos. As Mark David mentioned, I'm from Cisco. I am not going to sell you anything related to Cisco. As a matter of fact, the talk is absolutely nothing related to Cisco. But I'm going to bring a couple of stories inside of Cisco on how we're looking into security, how we're also investing in our internal teams as they experiment into recognizing some of the security issues that we're actually introducing that should have been, if a lot of these questions should have been asked 10 years ago. But we're going to start today with an overview of RAG. How many of you actually use Retrieval Augmented Generation nowadays? Okay. How many of you actually do it in production? Exactly. So I'm going to go over a few things related to that. Last week, I was in Vegas and I was presenting at a Cisco conference, but I was presenting to a whole bunch of CEOs and CIOs of different companies around the world. I asked exactly the same question. It was exactly the same answer, right? And one of the challenges is not because of the technology, it's also in some cases because of the fear of security, don't having a good plan for, or even a data strategy within the company and so on. But we're going to go over, a little bit of this. So for those of you that did not raise your hand, excuse me, we're going to go into a little bit of the differences between RAG, fine-tuning, and of course, training a model from scratch. We're going to go over different related security topics related to embedding models, the selection of those models, why is that relevant? Also, vector databases. This is very near to InterSystems' heart because you guys actually now have a vector search part of your Iris infrastructure. I am not familiar with it. So the things that I'm going to be sharing here are going to be more into a generic standpoint. And you're going to see a few references to open source technologies and other vendors as well. But I know that you also develop and offer that to your customers. And I'm going to talk about security implementations and security considerations related to the retrieval process, and also how to maintain visibility and control. And hopefully we'll breeze through this and we have a time for Q&A at the end. So a little bit about myself, very, very, very fast. I lead the security efforts for securing AI for all our products and Cisco offers, so cloud offers like WebEx, all the way to things like Splunk that we just acquired them. Part of an organization called Security and Trust. So the product security office is there, an offensive security team. It's actually a pretty big team within Cisco for security research. Insider threat, the traditional CSIRT, you name it. We are about 950 people now, and actually growing now with Splunk. I'm also part of the board of directors of Oasis Open. It's a standards organization, so I'm chairing a few things in there, as well as the first PCERT SIG, so the Product Security Incident Response team. Typically, I'm not in a suit. I am an offensive security / incident responder, so I lead the Red Team Village at DEF CON being the biggest hacking conference in the world. I recognize actually a couple of you probably have been in the village before. And I'm author of some books, and basically most of them are to raise my monitor, so they can be used to raise people's monitors very effectively. So my call to fame is that I have written a lot of books that a lot of students have solved their neck problems for quite some time. But anyways, everybody knows that there are three ways that you can leverage LLMs or any AI model for that matter. You can train one from scratch. super expensive, requires tons of data, significant infrastructure, and a lot of expertise. Only a few companies for now are training these larger models effectively. The industry, depending on who you talk to, you're going to get different answers, but the average that we're seeing is about 30% success rate, even on training from scratch, and it's because of the data. Even in fine-tuning, it still requires expertise, it still requires some type of infrastructure, definitely a lot more attainable, and in many cases, actually, the success rate is not that big. So a lot of people, every single company, every single board of companies are asking all their employees, what can we do with AI? What can we do from it competitively? How can we use it internally to accelerate our business processes and so on? And most people are looking into retrieval augmented generation. In other words, taking your data, and then the main concept is, of course, the grounding of reducing the likelihood of hallucinations. But the reason that it's a lot more attractive is because you can potentially do a lot of things using these newer implementations of LLM, requiring less hardcore data science. As a matter of fact, this is my first story. At Cisco, my team, I mentioned 900 plus people, I did a little bit of a carrot on the stick type of event back in November. And I told the whole organization, we're going to do an innovation challenge. Everybody, whether you're a PM, a software developer, and so on, is going to experiment with AI. And the main purpose was kind of to crowdsource all the security questions that probably we're going to get. And again, this is only a section on the company. Think about that everybody else is doing the same. But at least to my organization, I did that. And I had a lot of people that are non-technical. I'm talking about typical project managers and so on, that they put LangChain, ChromaDB, and they were able to actually experiment and Streamlit, and they had a chatbot. Like they have never programmed before, and they were showing how they're actually doing this. So a lot of the things are being abstracted significantly. A lot of the newer implementations and libraries like LangChain, Llama Index, and everything is making it a lot more attractive, for organizations to play with. Now, I am going to have these slides along with a whole bunch of different links available after the class or after the presentation. And then I also have a QR code at the end that will summarize all this for you. Now, I'm expecting that you will not be able to read these, but a lot of organizations throughout the industry are putting their heads together to see what are going to be the guidance that we're going to provide the rest of the industry on how to secure this implementation. So NIST, of course, is doing a lot of it's putting a lot of effort into this guidance, and there are 5 different working groups within NIST. I actually personally participate in 3 of them. And this is the output of one of them. And the link in the bottom, again, they're trying to come up with a good way to define even what is an AI security vulnerability, the taxonomy of what is an adversarial attack against an AI system. Why? Because even if these should have been questions that we asked 10 years ago, if you ask 5 people, you get 10 answers. And we need to actually come up with better ways that everybody's on the same page, because this is going to get regulated, right? So this presentation, again, is going to focus mostly in RAG, because it's what most people are doing. How many of you are training model from scratch? Fine-tuning? And again, a few of you are doing it, most of you are doing RAG. So I'm going to concentrate here on this. So again, this is the 5-second introduction of what is RAG. You can use, I don't have a pointer, but you can use your own data. In my case, I'm a security nerd. So in my example, I have security best practices, vulnerability information, the root cause of vulnerabilities. So in other words, CWE, common weakness enumerators, for those of you that are not familiar with the acronyms here. And I can convert that data into embeddings, basically, into vectors, to numbers, and then store that into, guess what, a vector database, which I think that all of you are familiar with. And then I can do semantic search, and if I have a chatbot, of course, have the ability to provide some context and then provide that information to the LLM to reduce the likelihood of hallucinations and to give you a better answer. That is one out of many other use cases that you can use this retrieval of context. That's another term that people are throwing out there because it's not only about vector databases anymore, it's actually to have also agents that determine I need to use this tool, I need to use these APIs, and so on. And I'm going to go over the ephemeral aspects of agents a little bit later and the security implications of some of that. Actually, most of the implementations nowadays. But that's in a nutshell RAG. Tons of hot libraries in the industry now. One is called LangChain, the one that I have in there, allows you to create prompt templates, agents. It actually allows you to abstract a lot of these for most organizations and most people. And if you look at it a little bit lower, there we go. If you look at it from a little bit lower standpoint, you can create, of course, prompt templates. Like in my case, I was actually using this example last week, and I said, you're an expert network administrator, do not make up the answer. So just like you saw before, you can have your own data, and you can create personas and say, you are an expert programmer, you will give me the output in this format, do not make up the answer. If you don't know the answer, you can put a keyword so you can also monitor it and see how many prevention of hallucinations you can do, and even have another implementation actually monitor this. And we're going to go into that of the concept of constitutional AI in the next few minutes. But then, of course, you can have a user or a machine providing another prompt. What is the benefit of eBPF in this case, Cisco? And then, of course, it will retrieve data from that database. Hopefully, you can retrieve good context, because that's the kind of a secret sauce in there, is the retrieval methods, the re-ranking, reclassification of data, and then you provide more context to the LLM, and you can get better answers. Agents can also retrieve info from APIs and tools, as I mentioned to you before, and I'm going to go over a few of those examples later. Now, what is a prompt? Most people think about a prompt of a human talking to ChatGPT. And yes, that's actually one side of the coin. The other one are system prompts, so prompt templates that you create, just like the one that you saw before. Of course, that one, it was super simplistic. But things that you can say, you are a doctor, or you're a radiologist, and you will recognize these patterns on these images. Or you are a security administrator, and you will help a SOC analyst, so a security operations center analyst, to respond to an incident, right? So you can create all these personas and then have these agents actually work together. And then, of course, AI can generate better prompts than Omar. And I'm joking, but not joking, because I'm actually using AI to generate prompts to then create prompt templates, because it's actually way better than me. Everything here needs to be monitored and secure. A lot of people are thinking about prompt injection and a human talking to ChatGPT and making it sound and provide answers, incorrectly, which you're basically the victim of it, because you're the target. But what if I can do a prompt injection attack that is reading a PDF with white fonts that a human cannot see, but the AI can actually read and then take some hallucinations? For example, at Cisco, we created this thing called a firewall assistant. And of course, we have the Splunk assistant. Everything has an assistant nowadays. What if I can manipulate a prompt that is not a human prompt, but some type of context, again, through any other type of data, and inject a route that I can bring down half of Europe? Or open a hole in a firewall that you will never be able to actually do for evasion purposes. May sound futuristic, but it's not. Believe me, that's what I do for a living, is investigate all the bad news whenever it comes to security. So how many of you are familiar with OWASP? Okay, the majority of you. So of course you know that they have the LLM top 10. There's a new version coming up probably this week. Prompt injection, of course, is the number one in there. For me, it's a little bit boring. You can read about it. I have tons and tons and tons of prompt injection attacks examples in a GitHub repository that I maintain. It's a personal GitHub repository that I use for my own benefit. And hackerrepo.org have dozens and dozens. I'm actually going to put a few more this weekend. And whenever I say a few more, probably a couple of hundreds, and where you can have Claude and GPT-4 and so on, and of course use this type of creative prompts to then manipulate a chatbot. But again, that's actually a lot more simplistic, I would say. So I'm going to deep dive into a few of additional security problems that you have to pay attention to whenever you implement these newer technologies. So again, that's the GitHub repository in case you actually want to visit to it. How many of you have done RAG with LangChain? Okay, a few of you. And so for the majority didn't raise your hand. LangChain is a library, Python, JavaScript, but again, one of a few. Another one is called Llama Index. Makes it really, really easy to implement these technologies. And I'm talking about really easy, as I mentioned to you, right? I'm going to do a demo, time permits, a little bit later. I'm going to skip that. But I want to go over the process that these libraries and these newer implementations actually go through that are abstracting for a human. And then people are experimenting and they truly don't understand what are potentially the security implications that this entails. So the first thing is, again, I mentioned that you are going to use your own data to have some better context for an answer, whether it's helping a security person, a doctor, a teacher, and so on. And then you basically index that information. And again, the indexing, there's so many different techniques that you can do for this, but it's one of the most important elements of actually, quote unquote, preparing your data for vectorization to make it really easy for it to be searched, similarity searches, and also, of course, for the retrieval process. Then you use an embedding model. How many of you use the OpenAI embedding model for your vectorization? How many of you use one from Hugging Face? What else did you use, the ones that actually raised your hands related to RAG? Was it already selected by the system? No? Okay, so typically you will select an embedding model which is not the same as your inference model. And OpenAI and of course Anthropic and a few other companies actually have made it really easy that you can have an API for an embedding model. And then what you're doing is you're taking your sensitive data, your documents, your data pipelines from, in my case, from like a Splunk type of a scenario, or a policy, or again, very sensitive information. And then you're saying, okay, I have a contract with X, Y, and Z, let's say Microsoft, Azure Cognitive Services, that they're not going to use my data for training. So it's a contractual agreement. But then along, everybody that is actually trying to experiment is using a random embedding model that is probably exposing your data all over the place. So again, going back to my story about that innovation challenge, these non-technical people had a lot of really interesting questions that we should have been answering 10 years ago. This is not new. Embeddings are not new. And then we started actually going over and asking the same questions, business units through business unit, business unit through business unit, and my friends, is Wild Wild West. So I started actually doing a lot of benchmarking with other very, very, very big companies. I'm not going to name them, but bigger than Cisco, and is the same, right? So the first thing that I will say as homework, go back and ask the people that are experimenting, those of you that have raised your hands about using RAG and everything else, what is the strategy of the approval of embedding models? Most people are using open source that they can control. Bear with me just a second. But in many cases, actually, that question has never been asked. The other thing is about the vector databases. You guys are spoiled. You have actually your own vector database implementation. But guess what? Most vector databases do not support encryption. And I repeat that. Most vector databases do not support encryption. And it's because, of course, there's similarity searches and everything. There's a whole bunch of additional newer implementations that can reduce the attack surface from that standpoint. But most of the open source or even commercial vector databases do not even support encryption. The other thing, of course, is a lot of different techniques for data preserving. I'm not going to go into a lot of details in there, but most companies do not have anything to sanitize their data. Like, talking about from healthcare systems all the way to cybersecurity companies. The supply chain security is another big one. How many of you know what Hugging Face is? Okay, so for those of you that do not know what Hugging Face is, think about like GitHub for exchanging models and data sets. Became super popular. It's not the only hub, but it became super popular. And by far, it's probably the front center of the open source movement for AI models. Most of the newer and older implementations of open source models use unsafe libraries like Pickle. How many of you are familiar with Pickle? Okay, a couple of you. And because of that, threat actors, already they know that this is a low-hanging fruit. So let's actually modify a few of these open source models that are in Hugging Face. And then, if you inherit whatever backdoor you actually have, then of course I can do a lot of things with your data. Well, 100 of them were pulled about a month and a half ago from Hugging Face, and that's very, very, very low. If you think about how fast this technology is evolving and how fast the contributions to these new models, just in February, there were close to 400,000 models in Hugging Face. I haven't checked today, but we're pushing to 700,000. It's like 650,000 or so, just to be conservative, because I haven't even looked at today. I can tell you that by the end of the year, it's going to be 800,000, right? So supply chain security is not new. What is new here is that we have really good inventory for software. You may think, oh, AI is just software. Yes, but no. Yes, because you can have a software bill of materials, the list of ingredients that make up software, and have the representation that you have, a library like LangChain really easily, OpenSSL. In an AI model, most of them don't even have a true versioning system. Like, you get renamed all the time that you fine tune, and you name it, Mark David and Omar's, model 23 based on Llama 3, and the model cards are less than effective. And what are the other things that you actually have to keep track? The data that was used for training, the training environment. Most people are realizing that this costs a lot of money in the cloud, so they're actually building labs to then fine-tune. Guess what? In those labs, they're omitting every single security best practice that there is in InterSystems, access control, true identity management. A lot of things are being omitted. So then you pair that up with the supply chain, models that are now being manipulated, the risk is actually increasing by the second, right? Access control is something that even kindergarten kids probably nowadays are learning, yet in very expensive GPU clusters, we're not putting that into practice. Now, vector databases, I think that I'm preaching to the choir, and you guys actually probably can teach me Again, most vector databases do not support encryption, and most of the open source ones. There are additional threats to vector databases, of course, unauthorized access, and I have to put an AI-generated image. Very simple, everybody knows this. Data tampering and corruption, of course, if you have unauthorized access, you can cause either inaccurate or malicious data retrieval of the RAG system. Service disruption, very boring, everybody knows that, right? So security one-on-one, and even scaling. In some cases, you're now seeing threat actors developing exploits specific for vector databases that the main purpose is not only to bring down the system or to actually have some denial of service condition, but it's to ramp up the money that it costs you for retrieval and so on. So if you think about inference and inference costs, a lot of people are focusing on that. And it's like, oh man, this is going to break the bank and so on. And there's no truly formula. There's token formulas, but not that much of something that you can implement for vectorization. Again, depending on the company, they charge you, for the vector store, but the retrieval process, if I rack up the money, I can literally disrupt somebody that is actually trying to put this into production. So we're seeing not early indicators, but we're already seeing attacks related to that to some of our customers. So there are some implementations to protect data in vector databases. One of them is called homomorphic encryption. How many of you have implemented homomorphic encryption before or know about it? Okay, so homomorphic encryption, it is not new. Actually, I think that the original research was in the 90s. But fully homomorphic encryption is very, very resource, it consumes a lot of resources. So that's why most organizations are not fully implementing fully homomorphic encryption. However, very recent studies, and there was one with UC Berkeley and Stanford with NVIDIA, they're very, very soon making it a little bit more attainable for large organizations to actually implement homomorphic encryption. But there's another concept called secure multi-party computation. How many of you are familiar with this concept? Okay, so this is actually allowing multiple compute nodes to do functions over their inputs while keeping them private and not decrypting data. Same thing, homomorphic encryption also doesn't decrypt the data. You're actually looking at patterns within the data and then perform those calculations in there. RAG implementations can be in a way that vector databases can be done in multi-party, in SMPC clusters, that then your retrieval process, without decrypting data, you can do some similarity searches. And this is actually something that is really catching a lot of vendors' eyes right now. I work a lot with another company, MongoDB, and they're using this with queryable encryption, which is another technique that is becoming very popular. Now, I do have this along with searchable encryption, which is a queryable encryption in a blog. Let me see if I can there, with a whole bunch of diagrams explaining those technologies, because I know that if you actually put a diagram like this, you're never going to be able to even see the first line in there. It displays a lot better in this monitor, but it will be impossible for you to read. So if you want to actually explore a little bit more of these technologies, I will say from searchable encryption, walking backwards, secure multi-party computation, and homomorphic encryption, that's kind of the ease of implementation. Easier, the second one is secure multi-party computation. A lot of people actually are trying to merge the two. And then, of course, fully homomorphic encryption as well. Now, whenever it comes to retrieval, the retriever part of Retrieval Augmented Generation is basically to be able to get some type of semantic comprehension of your data And in many cases, yes, it is to a vector database. Excuse me for a second. But nowadays, you can have agents that can say, give me the top 5 documents from this vector store, query this API, because the question was related to, I don't know, the weather, right? And then pull up this tool, a calculator, a financial calculator, and so on, and then give me an answer. So it is a chain, no pun intended, that's actually the research, chain of thought, and then chain of steps on where these are actually taken. And these agents and this process is very ephemeral. So in other words, very temporary. That based on the prompt, based on the question, based on the task, they may assist right now, and they will never assist again, ever. So think about incident response. Think about even looking at reproducing a vulnerability. Mark David actually was, and still is, in a product security team. So whenever somebody tells you about a vulnerability like server-side request forgery, buffer overflow, cross-site scripting, it will tell you, hey, these are the steps that you will take to reproduce this vulnerability, right? Now think about these systems. Hey, at 3 o'clock in the morning, I saw this, but I never saw it again. Good luck, boom, right? You investigate, tell me what is remediation. Now, what is remediation? Is it pulling the plug? Are we becoming really, really over-reliance, which is another element of the top 10? And if I have a summarization agent, that in my case in Cisco, I'm going to point fingers to them. If I have WebEx to summarize my meetings and give me the action items and everything, I can easily pull that plug, right? But we also created a generative AI implementation that even with 80% packet loss, it reconstructs your voice, and now you have crystal clear audio forever, so you will never have a broken connection. And I was a little bit adamant, I'm the security guy, so I'm the first one that's gonna hack this thing. I was like, nah, that's not gonna work, and actually it's pretty impressive. But what is pulling the plug in there? Am I gonna pull the plug and then all the WebEx calls are not gonna be able to do? So whenever it comes to incident response, and even though this super simplistic process, we have to start answering those questions again that should have been asked a few years ago. The other thing is query validation. Of course, validating the content, the output. A lot of people actually monitoring only the inputs and prompts, but not the output. And doing this at scale, it is easier said than done. So guess what? The joke of using AI to monitor AI, the concept of constitutional AI, it is true, right? And that's the only way that you're actually going to be able to scale. There are some RAG evaluation frameworks that are starting to do this. This is an open source one called RAGAS. They have some metrics related to how effective. The evaluation is mostly around accuracy and effectiveness, but also a few security elements that we're actually collaborating with them. And for those of you that are familiar more with hardcore data sciences, I think I saw a few of you in the back, related to fine-tuning and so on. There's tons of metrics for accuracy, tons of them. There's metrics also for bias. How many security metrics are there? Pretty much none, right? So we're trying to see what are the ways that we can effectively monitor whether you have a RAG implementation, fine-tuning a model, or training from scratch, and then using the technology to definitely accelerate the process, because us humans will never be able to actually catch up even with the things that exist today. Now, this is the only thing that I'm going to talk about that is somewhat related to Cisco, but it's actually to give you an example of the things that we're trying to figure out and make it easier for customers, or even internally to Cisco. We have an organization within Cisco called Outshift, and basically is the emerging technologies. So we have a quantum lab in LA, and a whole bunch of emerging technologies that we're putting a lot of money into it. And they have been working, a lot of data scientists is there, and we're hiring. But we've been working with, of course, AI implementations for a little while. Now with generative AI, we're trying to see what are the products of the future or the things that are probably going to be ephemeral. Since everybody's jumping in RAG, and there's a lot of contention into the nerd world of is RAG dead because of the context window or not, we dedicate a pretty big team to look at this technology. But the task that I gave them back in January of last year was how we're going to monitor this. Help me, because what is going to be the incident response of the future? There's none of the tools assist. Now that we're talking about natural language, right? We have to use tools that will potentially recognize that. And what is even forensics in the case of a model, right? So you have reproducibility, you have, the incident response aspect of it, but what is even forensics? Like in the traditional system, you dump memory, you collect something like a memory dump or a core dump and then put into a volatility or put into, in the case of Cisco, tools that we create, pretty easy, right? And even though I say pretty easy, it's not that easy, but in the case of a model, it doesn't assist. So this team came up with a few different elements that we're actually using internally in the IT space at Cisco. So whenever people want to put a RAG to play with their data, and we have so many use cases, just in my team, I have 137 rotating use cases, a whole bunch of them are overlap. The more people that experiment, cha-ching, the more that we actually make either the inference models more lucrative, or we waste a lot of money in duplicate efforts. So this tool that they call Motific, and now Cisco is going to try to sell it, but this tool, what we have seen internally is that if you build an ecosystem that you have approved APIs, approved data that they can use depending on your data classification policies, it makes it easier for people to say, hey, I did something with AI, and then at the same time protect the company and protect your data and so on. So if you don't abstract this thing and make it easier, the more people are going to continue to experiment, or just because they saw a YouTube video that somebody actually did something with a library, probably they're exposing your data without you knowing, right? So we have a few use cases. Again, it's not to sell you anything, but the team actually published a few use cases and case studies related to how we're doing this AI governance within Cisco and so on. That they have a few demos in there. Any questions? Yes, ma'am.
How do you view things like being able to have like a trusted supply chain focus on like learning models, or being able to have like a rollback or data? Either the AI starts to hallucinate or is not replaced by something. I'm seeing a lot here lately about things like nightshade plays or like AI generated images, things like that, to protect like artists from that kind of thing. So is there, do you feel like there's, I don't feel like there's a good strategy yet about how we need to do that, or even understanding about how that would work, but are you aware of anything that's ongoing?
Yes. So the question was, and it was a little bit hard, so correct me if I'm wrong. You start with the supply chain, so how can we protect our organizations and the supply chain of AI? That means the model, the libraries that we're actually using to use these implementations and so on. And then the second part of the question was around synthetic data, and then marking that. Is there any applicability into the two, and how you're seeing that evolving? Is that fairly accurate?
And the idea of if something goes wrong, how do we
Oh, yes.
to take out the wrong learning?
And then the remediation part of it, what is the remediation? So I'm going to start with the supply chain, and the things that by the book that we're doing, and reality is a little bit different. So I'm going to start with the by the book, and I'm going to tell you the bad story. So the by the book is we do have an AI governance team at Cisco. Big team. It is mostly led by legal, right? So big stick and so on. The tools, just that team, have gone to 3 different vendors for AI governance, because there's no tools in there. I mean, literally, within months, we're changing tools and evaluating them. And I'm talking about like almost put into production, a lot of efforts and so on. And we decided, hey, we're gonna build our own, right? So even the inventory part of the supply chain is a challenge. What I'm seeing in the industry is, first, the tools now are beginning to pop up, but the process is non-existent in most organizations. Like, it doesn't assist at all. And if it assists, it is a self-reporting process. So that means that I'm an engineer, and then I have a responsible AI effort, and if I'm building something, I'm gonna go through this process. Guess what? If that process is very convoluted, what are we gonna do? We're gonna take the shortcut this way, because I'm not gonna go through this 50,000 step process. And that's what we were seeing. A lot of people actually taking shortcuts and everything else. So what we're doing, kind of using our own technology. One thing is called Panoptica. Actually, the same team created that thing. Is another one in the industry is Wiz. If you're familiar with cloud security, you have a really good visibility into the cloud, the APIs that you have, the usage of the APIs, the technologies that people are putting in containers or VMs and so on. And then for on-premise, and this is mostly for products, we use software composition analysis tools like the Black Dots of the world and so on. And in there, what we do is we do not rely on humans for registration. And every time that there's a new inference going out to Anthropic or OpenAI or LangServe in Llama, not Llama Index, LangChain, then we start basically auditing in an automated way to those people. And I say, hey, you haven't gone through this process, and the more that you ask, the more you find, right? So it is whack-a-mole right now. There's no single first. The second part of synthetic data, NIST has actually a working group right now focus on the guidance for synthetic data. For us, at Cisco, we're looking at it from two different angles. One is for the disinformation and manipulation, within the company. And if you think that it's only for deepfakes because of Tom Cruise or Paris Hilton and so on, no. It is against the executives of pretty much every company. And to catch that attention, as a matter of fact, literally 2 weeks ago, we synthesized our boss's boss, Chuck Robbins from Cisco. And after we announced the number, we put a video on his face saying that we're pulling out of China. And then, of course, everybody freaked out. I was like, well, that's happening right now in a lab, but it's probably going to happen in a couple of months, right? Or, so in the industry, what we're doing for disinformation, I'm going to start with disinformation, I'm going to go into the second one. There's shameless plug. Part of the board of Oasis, if you have an Amber Alert in your phone or SAML for single sign-on, those standards are Oasis standards. So we started this open project to have a machine-readable cyber threat intelligence for disinformation. So if you think about sticks and taxi, if you're familiar with threat intelligence, it's the same analogy, but in this case for disinformation. Why? We kind of are giving up. The tools are going to get better, and for you to detect synthetic content that is like that, it's a matter of months, right? That is going to be ineffective. So what is the best method for you to tell whether your executives or your customers or your business partners and so on, what is that? And it's actually an open project called DAD, Disinformation Edit Design. And then the other one is everybody's suing each other because of copyrighted material. So what do? You actually use synthetic data. And we're using a lot of synthetic data inside of Cisco, generating to then train other models and then failing and then not doing it well. So that's another effort that is outside of pictures and so on. that you have to also pay attention to, because garbage in, garbage out. So there's a lot of efforts on how to monitor and detect bad content that is being now generated by AI.